Aloha, Richard Halverson here. This is ITS388AL, and we are in around week 10 or 11. We're in chapter 7, and today I'm going to go over the greatest common divisor assignment that we have for this week. So let me share my screen here, and so here we are in week 10. And we are going to do this programming assignment. Let's take a look at it. And basically, we are going to implement this greatest common divisor program. This is what it looks like when it's in C++, very similar. Very similar to C#. And this little function here takes two integers, and it makes sure that they're both positive. And then it does this loop here where it takes x mod y and gets the result of x mod y. And then it shifts y into x. It shifts that result into y. And it checks to see if y is greater than 0. If y is greater than 0, it loops again. And what's going to happen is as y takes on these modulo values and y becomes smaller and smaller, eventually we will get to a point where we will divide some number by some number and it'll become 0. Y will be either greater than 1 or 1. It should never be less than 1 or 0 even, because of this loop condition here. So when the result of x mod y is 0, then we know that x is divisible by y. And so at that point, we have as y, we have our greatest common divisor. Turns out that that's the way this works. And so y gets stored into x. N, which is 0, gets stored into y, and then this checks if y is greater than 0. The terminating condition is that y will equal 0 because this is 0. And then we drop through, and we're going to return the previous y, not this one that was just set to 0, but the one just before that into x, and that's what we return. Okay, so that's how the algorithm works. And we just need to implement this in assembly language, and then write some code around it to be able to read and write, read the integers maybe from the user, and to display out the results. So let's download our project here, our starting project, put it on the desktop. And let's unzip it. And we can open it up. And it's this one here. Let's make sure that we open it with 2019. And so here we are. And it's this add to sum program, as you know. And so let's open this up. And the first thing let's do, let's change the name of it to greatest common divisor. I'm just going to name it GCD. Good enough. Name this GCD finds greatest common divisor of x and y. Let's see. Let's include since we're going to use the I/O in the Irvine library. Let's include that. And I'm going to see if this builds. It does. it's got a double model in there. We can comment this second model out if we want to. And by the way, if you don't see this output window down here, you can just go View Output, and it'll appear. All right, so what we're going to do, okay, so first of all, before we go any further, let's take a look at how we're going to do this mod operation. You recall the last from the last video, the division instruction. We sort of left off at the division instruction, and the division instruction takes a dividend and divides it by, and the result is a quotient and a remainder. And so the dividends, the way this works is the dividend, and let's use the largest word size here. Let's use 32-bit words. So the dividend is going to can be spread across EDX and EAX. So you can take up to a 64-bit number, because it's two 32-bit numbers, a 64-bit number, divided by a 32-bit divisor, and the quotient will go into the EAX register, and the remainder will go into the EDX register. Okay, so let's just and we're going to be looping here. We're going to be looping. So why don't we say that dividend divisor, and this is the remainder. So let's use X can be this, EAX. Y can be N will be EDX, because that'll be the remainder, and then Y can be this changing divisor here, which we can use another register. We can use EBX for Y. So and that way we should just be able to loop and shift these registers around, move these registers around here, and each time we come back, this will be EAX, this can be EBX, and we do the division, and EDX will be here. So then we move EBX into EAX, and we move EDX into EBX, and then we check if EBX is greater than 0. And if it is greater than 0, then we loop back and go back to this do statement here, to this do here. All right, so so in fact, I'm going to copy this. Copy. And I'm going to put it up here at the top. I'll just, I will put it, I think I'll put it up here. And apparently, I've seen, you can do comment, exclamation point, and throw a bunch of lines of comments in there and end it with an exclamation point. And just to prove that this works, I'm going to build this again. And it's fine. Okay, so so this is the algorithm, and so the first thing it does is we check to see if X is. So here we're simply gonna let's see, is this tabbed out? Let me just tab. This will be if X is negative, then negate. We can just use the negate instruction. And this one also, if Y is negative, then negate. And that'll take care of that. And here we're going to be, we can just, in fact, we can use do as the label. In this one here, we will, let's use, use EDX as N, because N is going to be the modulo, and if we look at the remainder, it's going to be the remainder, and that's EDX when we're doing 32-bit operands. So let's have EDX as N, and let's have EDX AX as X. This is messing up. Why is that I there? There, it's gone. As X, might as well. We're just going to start out. And when we do this, we're going to have to set EDX equal to 0 because if there's any garbage in EDX, it's going to be taken as the upper order of a large integer there, which we don't want. So EAX will be X, and we might as well use EBX as Y. Okay, and so here we'll just use div instruction. Just put that there for my note, and then here we're simply going to move EBX, which is Y. Let's just put our note here into EAX, which is X. And here we're going to move EDX, which is N, into EBX, which will be our new Y. And here we're just going to compare Y with 0 and jump to the do up there if greater. And here X will be in EAX, so just return. All right, so this is how we're going to do it. Let's create let's create the this is the main, and at the end of the main P, let's put our procedure down here, our greatest common divisor procedure down here, and get this translated so we can see what it looks like. So I'm going to put some comments in here, which you should always have. Right here, it's going to be, I'm going to name the program calc GCD. How's that? And it's going to be a proc. And we are going to calculate the greatest common divisor. And we are going to receive X in EAX, and that's the first integer, 1. And we're going to receive Y in EBX. We'll just, so we'll hand these, we will send these arguments to this procedure using the registers. This is going to be integer 2. And it's going to return X in EAX, which will be the greatest common divisor. Okay, so this is our nice documentation at the top of our procedure here. And okay, so let's be a polite procedure here, and we're going to be using EBX and we're going to be using EDX because we're going to be using them here. We're going to be using EAX, EDX, and EBX. So let's push. And we don't need to save EAX because we're going to return a new value in EAX. So, but let's preserve these other registers that we're going to use. So let's push EBX and push EDX, and we will return them when we're done. And so I'm going to, down here, I'm just going to, might as well put that in now. We're going to have a return. No, we're going to have a pop EDX. We've got to pop them backwards, and we're going to pop EBX, and then we're going to return. And this is going to be the end of our, and it's going to be NP. And so the greatest common divisor code we're going to put in here. All right, so the first thing we're going to do is we're going to do this absolute value thing. So we're going to check if X is negative, and if it is, we're going to negate. Same with Y. So let's check if X is negative. That's EAX. This is going to be. So compare CMP. Doesn't matter if you use uppercase or lowercase. EAX with 0. And this is going to be something like if X is, we're going to check if X is greater than or equal to 0. So we go, so if X is greater than or equal to 0, no. So with these assembly language programs, when we're doing the if part, we are testing if we're going to skip the then part. We're going to jump around the then part. And if there's an else, we would jump around to test the else. But so down here, we're going to, this is where we're going to negate. So let's say it passes, we will negate EAX. And we do that, X was negative, so negate. So here, if X is positive or X is greater than or equal to 0, jump if greater than or equal over the negate. So we could just jump to LX, just call it LX, and LX is here, LX. Okay, so we compare EAX with 0, comparing X with 0. If X is greater than 0, jump over the negate. So then jump over negate. It's a better way to look at it like that. Okay, so if X is greater than 0, then jump over this negate. And so it jumps over it, and we're here. Okay, now we have to do the same thing for Y. So I'm just going to copy this. And this is EBX. Remember, Y is in EBX. If Y is greater than or equal to 0, jump over the negate, and we're going to call this LY. Why not? This is LY. And we are negating EBX. Y was negative, so negate. Okay, at this point now, both X and Y are positive. Okay? Now we can go into this. Now we can go into the do part. Now we can do this part. So how are we going to do that? We're going to loop, and we're going to do this division, do some moves, and come back. So we might do something like, let's see. Let's call this do. Let's just have a label here called do. There, do. I'm going to do lowercase. Do. And what are we doing? Well, we've got, we're going to do div, let's see, X, div, EBX, okay? And this is, EDX equals EAX mod, which is the remainder of EBX. And this is the same as N equals X mod Y. Now, the trouble with this is this division operation, it assumes that EDX, the EDX, because that's the top part of the divisor, the dividend. The dividend is EDX plus EAX. This is the higher order, and EAX is the lower order. So we need to, we actually need to clear out, move into EDX, comma, 0. We need to zero out the upper order word, so so the division works correctly. Okay, so now we've got in EDX we've got the N is in EDX, and so now we need to do this part, and so that's going to be move into EAX, move EBX into EBX, and that is the same as EAX equals EBX, which is the same as Y equals X, which is what this is. No, X equals Y, sorry. EAX, oh yeah. X equals Y. And the next we're going to do, we need to do the move Y, EBX gets N, which is EDX. And so we've got EBX equals EDX, which is the same as Y gets N. So that would be this here. And then after that, now we need to compare if Y is 0. We need to compare if EBX is 0. So compare CMP if EBX is 0. So this is kind of like the while EBX is greater than 0 kind of thing. So we do the comparison, and if EBX is greater than 0, we jump. So we jump if greater to do. Jump to do. Jump to do line, which is this. Okay, so let's be consistent here. Let's make this capital D. D O. This D O. Doesn't matter, it can be lowercase. D O. Jump to do. Jump to the do line. All right. So that, and if this fails, if this jump fails, in other words, EBX is equal to 0, then it's just going to pass through. And we already have the previous EBX. You know, we already have X. X is the one we want to return. X is EAX to EAX, and that's that is what gets returned. So, you know, X to be returned is in EAX. Okay, so I think that takes care of our greatest common divisor program. And so now let's add some stuff here up at the top so we can read in from the user and read into integers from the user and display out the greatest common divisor results. So up here at main proc, I'm gonna probably have a loop. Let me get rid of this. I'm gonna have a loop, so I'm gonna call it L1. And what I'm gonna do with this loop is the first thing I'm gonna do is I'm gonna oh, I gotta have some. Let me do it. Let me throw a data segment in here. Data. And I'm gonna have a string to request an integer. I'm gonna say integer request. I'm gonna call it integer request string is going to be a byte. It's going to be enter integer ending with a 0, and I want to display out answer string will be byte GCD is quote comma 0, and that's enough. So first of all, let's display out reading in the first integer. So move into EDX. This is the character string that we're going to write out. Offset int rec str. So that's going to display integer request, and call write string. And then we're going to call reading in the integer. And we're going to make it so if the user enters in a 0, then we can just quit. So I'm going to do a JZ, and I'm going to quit. And so we'll have quit, I don't know. Where's NP? Down at the bottom here, I guess. All right, so if it's 0, we quit. Otherwise, let's move this into EBX, and this can be our Y. It doesn't matter if X and Y are reversed or are exchanged. Move into EBX, move EAX into EBX. Assign to Y. And then we gotta read it in again. And EDX probably still already has our request string, so I think we can just call write string again. And call read int. So this reads in X, and let's assume, I guess, that this could be 0 too. So JZ quit. So that'll quit if the guy enters in a 0 for the second operand. And so then I guess we're ready to call greatest common divisor. All right. And then we're going to want to display out the results. So let's do move into EDX answer string. This thing. And call write string. And then we got to write out call. Oh, it'll be an EDX. Presumably, EAX has not been destroyed by write string, presumably. And let's call write decimal value. And let's put in a call CRLF. Let's put in a couple carriage returns. And so then let's loop back up. Loop L1. Let's not do loop because that's going to decrement ECX, and if ECX goes to 0, it's going to quit anyway. So let's just do JP. Jump to L1. All right, I'm gonna see if what this does. Build. Line 42. What's the matter with line 42? Move offset. Sorry. Let's build it again. Output. I guess it looks okay. So let's run it. Let's get rid of this breakpoint. Let's run it. And yeah, enter an integer. How about if I enter 169, 39? Greatest common divisor is 13. For some reason it quit. When do I quit? Let's see. JZ. Do I have the right jump command? Let me see. I might not have the right jump command. Let me open up the book. Is it? Let's see. Hold on here. All right. It's not JP. I looked up the in the back of our book, page 620. JP is jump if parity, and I just want JMP, unconditional jump. So let's fix that. All these instructions. All right. Let's try this. Build. Looks okay. Debug. Let's see. 25, 5, 15. Okay. Minus 52 minus 169. Greatest common divisor is 13. Okay, yeah, so this looks pretty good, and so this should get you started, and you should be able to put something together for your assignment. And so I'm gonna close it up here, and I hope this helps. Thanks for watching.